Hello, and so to speak, to global economics, and so to speak, to our last lecture that you then can fully go into your term paper. Some of you have fortunately also already started to look a little bit for data for your country, and for this in general, if you have problems in finding a reasonable time series until 2008 when you should start. I think it was you or someone, no, then it was a colleague from you. And they said, well, it's not so easy to find something data within the financial crisis. So when the time series is starting at 2010 or so, it is also okay. Or just ask me and maybe I find some data. Um, because also this is also what this term paper is about, that you see it is not just typing, I want to have the growth rates or inflation or something like this. This term paper is also about to dig a little bit deeper into the internet and finding relevant data. And also, I think this will be then the more or less the first time when this, yeah, maybe works, but I say also only maybe. You can use and you should use, of course, artificial intelligence, but then sometimes you get an output and then you have to look for the sources. Where comes the data from? And if you want to match different time series, then you have the problem, is the quality of the data okay of both time series you want to match, or the uh, is this time series deduced in the same way? So, for example, you cannot match just the time series of the growth rates of a country from the World Bank and the International Monetary Fund. If you compare them, they differ. And as I know, the time series of the World Bank, they go much further into history, I think around the 1960s, while the general time series at the Monetary Fund start at 1980. But on the other way, the International Monetary Fund has more actual data. So let's take some developing country. Then you maybe find at the World Bank a time series until 1965, but 2023 and 2024 is missing. And then you can say, well, great, I take the data from the World Bank and match it then with the data um, from the International Monetary Fund. But you see then that the overlap of 1980 until 2022, that then you will maybe have different numbers within it because they used a different approach to calculate the growth rates of a GDP, for example. And this is then, yeah, always a problem. Then you have to mark it, and sometimes it is even not a good idea to just mix different time series. Okay, but this only because I was asked by a colleague of you. So then let's go back to this yeah, little econometric in quotation mark approach. We now want to do the analysis of Okun's law using especially the growth version, recalculating this into this form, because then we directly have the data for GDP growth rates. We have the data for the change of unemployment, and then this is the Okun parameter, and potential GDP growth is then the second parameter, and these two we want to estimate. And for this, Okun's law is also a nice possibility to calculate this theoretical value of potential growth rate. Because also I did it with you just by averaging over the last 30 years, for example. But this, of course, comes then out of the real data, and there we talked about potential growth. Well, it is a theoretical concept. It is what we could potentially produce and not what we have produced. Well, an approximation is okay that you say, on general, because of the business cycle, we are fluctuating around, and if you then averaging over 30 years, then more or less these fluctuations cancel out with each other via the averaging process. But unfortunately, if we take the recent 15 years, we always have these huge splines because of the financial crisis, Corona crisis, and the actual bad situation which we have. So especially right now, it is not a very good approximation just to use the average of the last 15 years in order to get an idea of potential growth, and therefore it will be maybe quite interesting what's coming out using the Okun's law, because you obtain not only this parameter, the dependence between unemployment and GDP growth, but also an estimation for potential growth rate. Okay, for doing this, I went quite fast through linear regression with you. So we want to find this best linear line. I think I showed you the US data. Yeah, here it is. So we want to fit to this cloud here our best line with the property of the minimum of the sum of the squared distances. And also then in order to obtain a number which, so to speak, let's go back again to this picture here. If this cloud would look like a circle here, now it looked like really like a lens, and so if we fit maybe some line like this through it, then of course, as I mentioned, compared to the average, this would be then dy over y bar, the average of all growth rates. And then, as I mentioned yesterday, it is using this linear line that the distances on average of all data points move a little bit more in the neighborhood of our new regression line compared to all single distances with respect to the average. This is what we are doing by this linear regression. And then I explained hopefully to you that then this correlation coefficient or this coefficient of determination then represents somehow an interpretable number how good our fit is. So if this maybe is 0.7, then we can interpret this by moving this line from the horizontal in this downward sloping line, means that with this we can explain 70% of the dispersion of our data. And these two things we want to do now, using the data of Germany. Oops. Well, this was Germany. Let's do this as an example because for the United States we had it already here. Where was it? Let's paste it in here. Or I have the data here. This we can do later on. Let's do it at first. The example for Germany, how you should then do it also with all the download stuff and so that you know what you should do. So you should use the data from the IMF data mapper. The guys who has already participated in my macro course, they know this already. This data source. Well, this you can cancel out. I think it will be quite hard to find reasonable quarterly data. This I haven't updated. Hopefully we find for every country data until 2024. And yeah, then of course, starting at 1980, we have of course the fall of the Berlin Wall, which globally changed the framework. We have also the dot-com crisis. We have the financial crisis. We have Corona. We have the actual situation. So just doing the overall regression wouldn't only be the best, wouldn't only not be the best choice because during these almost 50 years, we have always events which really changed the world overall, and then also the economic framework for your specific country. Maybe also in your country, you even have also other events which really changed something. I don't know, an extreme government or something like this. And for this, then I recommend that at first we are doing the overall regression, just using the period from 1980 to 2024. And then we look at these sub-periods, and this will be also actually interesting because then we will see the change of the potential growth rates that we then really can interpret, well, what was maybe the growth rate until the dot-com crisis. Had the dot-com crisis a general impact of the growth situation of the country, or even it was better afterwards? So you later on then you should look for meaningful sub-periods to split your data, and then also, yeah, just try to interpret these sub-periods from the general background in these years. And of course, don't forget, sometimes the students have done this. Well, great, the Okun parameter is where I wanted to have, and the R squared was 0.1. So more or less your regression is, although the parameter is where you want to have it, with an R squared of 0.1, 10%, it is almost meaningless. So you have to take all these numbers together. But then we start. Oops. So then let's go to the IMF data mapper. And then I think to the World Economic Outlook. data sets. Yeah, here we are. And then you have here the real growth rate. And we want to use Germany. Here we have Germany. Oops. Select country data. And hopefully it works. Oops. Germany. Real growth. IMF. Oops. Why do I have the other ones? I don't know. Bearbeitung aktivieren. Yep. So, but anyhow, I have, oh, I think at first, yeah. So this you have to, if you don't want to have the data in the download, but I think this is clear. So then we take this, Okun and Germany. So I always transpose then this data because horizontal is not, in my point of view, not that easy to handle. So then a right click, you can change the format down here and transpose. And I only want to use the data. Oh, these were the years, and the growth rates are these ones. Again, right click, content, and transpose. Sometimes if you are copying data, then there are sometimes within formulas. And if you want only the numbers, then you have to choose here that you only want to have the numbers, because otherwise you copy the formula, but within your Excel file, the formula doesn't find the data which it needed. Okay, so then we have it here, and real that we are know what kind of data, and also the source I also always put in here. Okay, let's take this down here, and this was then dy over y. Then we need unemployment. And the unemployment rate we find here. Germany. And let's delete the other ones. Download. Germany. Unemployment. Where is it? So then you see the time series lasts until 2030. How is it possible? Well, this is a forecast of the IMF. Well, this we don't want to use, so I delete it. And to be complete, both are given in percent. Oops. Well, maybe you can help me now. What we later on want to do is we have gy equals a delta u minus gy star. Now I have my raw data. What do I have to do now with my raw data that I then can start with my linear regression? For this, you have to look explicitly in the formula we want to use. So not the technical part now what I have to do, but at first I have to make a little manipulation of my data before I can then start with the technical part. Yeah, this is then later on for the technical part. But the first one, I cannot use directly this data which I have here because the growth rate, this is okay, this I directly have, but the other one, so this would be in general my y(a)x plus b, but the x, I have delta u, so the change of unemployment. And right now I have the unemployment rate. So this x, I have to calculate the change of the unemployment rate. So 4.8 minus 3.4, 6.7 minus 4.8, and so on. So this will be then delta unemployment, this minus this, and this of course for all data points. So then the y value, this and again here. So that you can see anything. Let's fix this. And yeah, well, and now it is your turn. We need the average of our numbers. Oops. Is it really that small? But anyway, it's possible because we have plus minus. But that is really almost zero. Well, I'm a little bit too long because I have to skip the first one because for 1980 I have no growth rate. Okay, then it is. And this would be the average growth rate. Yeah, for linear regression, now you can use the general formulas. Where did we have it done here? So this was these two here. It's the slope or the vertical axis. You can use directly this, or we can also do it with the concrete calculation. This is in general up to you. Well, let's use at first the formulas, then we have A would be then the slope using all these values until here. And the vertical axis, this would be then vertical axis and the unemployment rate. This should be the same as, this puzzles me a little bit. Is this really 0? This shouldn't be the case. The average meets this one. Well, this can be by chance, but let's see how the data overall looks like. For this, we look at a diagram. And so X is E and Y is F. This is okay. Where is it? dy over y and du. Well, here you see compared to the long time series of US data, and US data was also 4 times the number because we had quarterly data. Then you see here, well, we can fit a downsloping linear line within these data, but I would suppose that the R squared would not be very high. Let's then also calculate the R squared for overall. This would be coefficient of determination, values of y, values of du. So you see here, then we have a quite low correlation coefficient of only 2.2, 0.22. So taking the whole time series, we obtain a result, but it is not very reliable since we have only an R squared of 0.22. Well, then we find here also a quite nice thing. We can do it directly, or what you also can do is you can click into the data that all data points are marked, right click, and then you have here the option of adding a trend line. Using this trend line, you have different possibilities how to fit your data, exponential, log, polynomial, whatever, or here linear. Then of course you have to choose linear. And now myself, therefore I cannot see it. Oh, not this one. This one here. So this is overall directly doing all the fitting, and of course we want to see what is the coefficient of determination, and we want to see what is the formula, what are the parameters. And then marking these two, hopefully we will see directly our regression, and here it is. But I have here 1.5522, and this is 1.3, and here it is also. Well, the reason why the average coincides with the estimation via the Okun's law is that the cut of the vertical axis, or that the average of all changes in unemployment rate is just 0. So we will see if we split now the time series in the reasonable subperiods, that then this won't coincide anymore. So this would be then for the period overall 180 until 2024. So here then you have to be careful to really interpret these numbers. Well, the Okun parameter, it is a little bit lower than the 2, which was found in the 1960s by Okun. But of course you have the minus sign, which is reasonable, and you have with minus 1.3 something which is, yeah, quite reasonable, what you expect, that you do not have this one-to-one, but that it is a little bit more, that you need more growth in order to reduce the unemployment rate by 1 percentage point. So this would be then what you should just by interpretation write some sentences, some little part. Let's copy this for inside, oops, here. And we do it for Germany. So, well, then let's say that the first reasonable sub-period would be until 1989, because then we had this turmoil because of the German reunification in 1999. This we can then just no, not that way, but this way. So, and I think now I can directly copy this. This is the 0.1. Yeah, this works. So let's see how this looks like. Again. This was the wrong option. This one. So here, maybe also from your school times, you know that this time period for Germany was quite stable. In the beginning of the 80s, we had reasonable growth rates, and also unemployment went also a little bit downward. So just from the general view on this period, we could say this has been a quite normal times. So in general, maybe then we would expect that we also obtain quite reasonable data from this, and that we follow somehow the general models. And Okun's law is one of the very general models which we are applying. So again, you can calculate all the numbers via the formulas. I will do it now a little bit faster by just clicking into the data. But for the future, for you also, be please really careful that always, if you only feed in the data and clicking somewhere, that you always know what you are doing, that you really know, well, this is what happens then, and that you really can interpret the data afterwards. And if somebody asks you, that you are sure for yourself, well, I know what I have done, because unfortunately, quite often, people doing statistics not knowing what they are doing. So, trend line, and we want to see the data. Well, and yeah, let's copy this just here. Oh, the time period we need. 1981 it was, no? Until 1989. And this was also here, 1981. So, well, then we have also a quite reasonable parameter here, but what is much more interesting is the R squared, which we have now with 0.77, so almost 80% is explained by our assumption that we have this negative dependence between economic growth and unemployment. And this seems also quite reasonable, a potential growth rate within these quite prospering time in Germany in the 1980s of 2.5%. And this maybe you can then do also for your country when you're interpreting the data, because you have read a little bit about your country, and then you maybe have an idea was where has been this period been quite prosperous times or not, and does this fit with your empirical analysis here? Okay, let's go further. The next one, and then you can play a little bit around with your data. So I will now just skip the year 1990 and 1991 because I directly know that this was a huge turmoil where due to the reunification we have more or less a totally new country, and therefore it is not very reasonable to take within a time series just this extreme change. But on the other hand, sometimes it's quite interesting just to try it. What is the output if I'm starting at 1990 or if I'm starting at 1991? And see, and that you then see, or let's do it like this. So the next one, then from 1990, and here we go then until the dot-com bubble, or what we actually we can do it a little bit easier. I can just copy this, I remember, put it here, and let's see. No, not this one, but this one here. And let's just change the period within here. So starting from 1990 would be 12, and until 94. Now I can't see this, sorry. Let's move this at first here. So again, so starting from 12 and 1999 is 21. And this 12. Okay. Well, and then this is from 1990 until 1999. Well, it doesn't change very much in the numbers, minus 1.6 plus 2.5, but you have now only an R squared of 0.44. So, yeah, the value of explanation of your model is now much poorer than before. You cannot rely that much on your interpretation of the dependence between unemployment and the growth. But then let's see how much this is maybe interesting. how much this would change if we start at 1991. If we keep this data in mind, this would start then at 13. Maybe it doesn't differ much. Oops. Okay, quite reason. It is only taking one data point out of your time series. It really dropped, and also the potential growth dropped. Well, in 1990, yeah, we had in 1990 this quite high growth rate of 5.7, but this was just by the reason that we had the new countries from Eastern Germany plugged together in our country. This just directly pushed a little bit our growth. And then we see it dropped quite a lot to 2% and then -1. And this was this little crisis which we had after reunification. When you remember, I think we talked about this last week. And yeah, this means maybe around the crises, play a little bit around with your time series. Take the crisis within your estimation or leave it out, and then maybe you find something interesting. Okay, but then let's go further until the financial crisis. Then from 2000 to 2008. This would be then from 22 to 30. Oops. From 22 to 30, and also from 22 to 30. Yeah, and this is not very surprising. What we then find here is that especially potential growth really dropped. And as you remember, for Germany, in the beginning of the 2000s, in the beginning of the new millennium, we had a really huge economic problems with unemployment people, a number of unemployment people of almost 5 million. And this we see here then also in our data, but anyhow, still with an R squared of 0.6, it is a quite reasonable fit, which we have here. Let's copy this also. Down here, and then comes the interesting part, the financial crisis. Yeah, now at first I take within the time series the year 2009 with the huge drop of, what is here the actual data for it, 2008 minus 5.6, and then I leave it out until Corona. And there I think you will see a dramatic change, I suppose, between the numbers. So let's start then from 31 until Corona until 41. 31 until 41 and 31 until 41. Can this really be true? Yeah, this is maybe that we will see it in a minute. That now we have a negative potential growth, which puzzles us. Well, but I think that this number is just due that we have within our time series this huge turmoil of the financial crisis. Let's see what happens to our regression data when we leave this number out. So this would be then from starting from 32. Yeah, and now you have a little bit more reasonable data. Here you have a lower potential growth. This is not very surprisingly. Well, the time after the financial crisis was quite good, but it was, of course, still not that good as before, especially after reunification. And already then, we talked about that our potential growth level has come down. And also what we see here is we have a very large parameter for the Okun parameter, minus 3.4. We would expect there some number between 1 and 2 if it fits, so to speak, the model. And then we also can recapitulate what has happened in this time between the two large crises. And then we have to admit this was a time of very much intervention from two sides, from fiscal policy and from monetary policy. Especially from the monetary policy, we started these huge programs of buying government bonds. And so this was then a time where the independent free markets we haven't seen. So it is then overall also not very surprising that a general market-based model where we want to explain the development of the economy via processes coming out of just looking at the markets and the match of supply and demand, when we are looking at a time period where, especially at the financial markets, the institutions, the Fed and the ECB, intervened massively by buying just government bonds via this institution, via the general institutions. This was a time where roughly 1/3 of our public debt we have hold, so to speak, by ourselves, because the European Central Bank has bought 1/3 of the public debt in the European Monetary Union. And then it is also not very surprising that the general macro models do not work like they should because of these huge interventions from the institutional side. And maybe you will find also something similar for your countries. I would think, especially if you have European countries, because then they, although I gave you not Euro countries, but of course they developed in a similar way like the countries in the European Monetary Union. But we will see what comes out in your data, but especially you see here when I take within this time series 10 data points, that then the 2009 data point with a minus 5.6 growth rate, that then the whole result of our regression is mainly driven by only one data point. And therefore also we have always to be careful how to choose our data set. Or let's even take both years within the regression. I think then there comes out nothing. So if I take the data point of 2009 and also Corona with minus 4.1, then the potential growth I think will drop below 2% or something like this. And this is not interpretable anymore. Yeah, let's just try and then how this looks like. This would be then from 31 to 42. Yeah, here now minus 5.6 and minus 1 because of these two outliers here. And this is what I mean. You can play a little bit around with your data set. Okay, question? Pardon again? Yeah. Yeah. Yeah, just try it. Maybe you can show also both. This is also then a result. So there's, well, here I have reasonable data which fits more or less my macro model with respect what in Okun's law is expected, and then I incorporate this crisis data, and this is then also a result. Then you don't get a reasonable result anymore, and then you can say, yeah, well, this also my data shows now that I have this special situation now in my country because the general models do not work anymore. And I can show that the models within this period don't work anymore. And also what we have here seen here within this time period in 2000, from 2010 until Corona, that it quite it still was somehow explanatory due to Okun's law, but not very good anymore. And this was actually a time because of these institutional interventions where our general market models not very well functioned because we had always interventions from the government or from the central banks, which yeah, really changed the market process dramatically. And of course, if you want to do forecasting, you cannot just say, well, these models has worked for the last 40 years and therefore they have to work now. No. Okay, this was from 2000. Have I already copied this? No, this was from 10 to 19. And yeah, and the last one is then quite hard because we do not have much data. Well, we can do it. The 2020 to use is not a very good choice. And also in 2021, we had the 3.9 9 the backswing, but let's see. But using 2021 would not be very reasonable. So only 4 data points is in general not enough to do really a regression. But let's try what comes out. Oops. This is then from 43 to 46. Yeah, very poor result. It could be also the other way around. If you have only a very small number of data points, that then the R square is very high. In this case, because of the turmoil of Corona, it says almost nothing, only here 0.1. On the other way around, if you have only 4 data points, then it could be that they're really in the neighborhood. But since it's only 4 data points and you have an R squared of 90%, it is also hard to interpret that you really have then a dependence between it. Yeah, maybe it is possible in order to find something for the actual situation, then you should look at quarterly data, that you have more data points. Maybe also I look up if I can find reasonable quarterly data for you, and then I provide it, and you can also look it up. Because doing this regression with 4 data points is not very reasonable. But in order to be complete, let's put this also in here. So, and that's what you then should do for your country. And please also start with a little explanation of Okun's law. Not very long, maybe not more than half a page or something like this. um, so that I can more or less see that you know what you are talking about. I think I put this also in the annotations of the term paper, or let's see, term paper. Warte jetzt. Will nichts anmelden. Oh, then I firstly save the video, not that my PC is crashing.